they're over here. So it's kind of what I want to get covered today. Might get it finished, hopefully I will. If we do, I'll start the next section. We've already done the 5-figure summary, but I want to do another one. I want to do it by hand. In particular, I want to talk about a new guy called an outlier. Once we've done that, I want to show you how to use salt to get a 5-figure summary and to draw box plots, because some of your homework questions, you hit the salt, and I want to show you how you go about doing that. And then last thing is a new thing I want to talk about is what's called a dot plot. And I'm going to show you how to create one by hand and how you can do it by salt. And there's one homework question right at the end where you create a dot plot. Right, so that's kind of the main goal for today. We'll see how we get on. I've kind of simplified things a little bit. I do tend to try as often as I can to get my data from you lot, so it's a little bit more realistic, but you can't always have that. So here we have a list of data. There are 19 numbers in it, and we are going to create a 5-figure summary, which is pretty standard. We know how to do that, but I'm going to do it by hand. And I guess I'll have a story with this one. This is 19 students in some class that pretend class that I've got. And would you believe this is how many coins they have in their pocket? This person at the end has a problem. Anybody who has 89 coins in their pocket has got some issue. I don't know what that issue is, but you shouldn't have that many coins, agreed? Unless this was the day you were going to the bank or whatever. So you have a set of data. There are 19 numbers. You're going to create the 5-figure summary. That guy there is your minimum. That's 1. This horrible number at the end, the 89, that's your maximum. Okay, got those two out of the way. We did only one of these, and one example's probably not enough to get the gist of it. But if there's 19 numbers, don't you take 19, add 1 and half it, and that tells you that it's the 10th number. Right, remember that little trick? How do I know where the middle is? Just dropped my pen here. Well, when there's an odd number of numbers, like in this case, there's 19 of them, the middle number will be guy number 10. So here goes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That guy there is the median. Right, that guy there. Now let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do you see how both, no matter if I count it from the left or I count it from the right, don't you meet at the same place? So there's only one number in the middle, right? So when there's 7 numbers or 27 numbers, the median is a single number. What do we do if there's 2 numbers in the middle? That'll happen when you've got 20 numbers or 10 numbers, right? So what did we do if there was 2 numbers in the middle? Like an 8 and a 12 or something, right? 2 numbers in the middle.
Did we add them and then divide them by 2? Or is that something else?
Yeah. So that's
okay.
Yeah, that's no, you nailed it. That's exactly what you do, right? If there's 2 numbers in the middle, right? Because half the time that's probably going to happen. The median is what you get if you add them in half. Right. Now, all we've got to, better put that answer in before I forget. The median number of coins that people in my class had in their pocket was 9, allegedly. Now, if you're doing it by hand, how am I going to do this? Yeah, you cover that guy up. You see how that 9 now separates the world into big half and little half, right? Big half, little half. And so I'm only going to be looking at these numbers here now. And these numbers here, the middle of them is called Q1. So let's see, there's 1, 2, 3, 4, 5, 6, 7, 8. Do you see how there's 9 numbers there? Agreed? Okay, what position will I look for the middle when there's 9 numbers? Correct. Somebody did that. 5. 1, 2, 3, 4, 5. It's that guy there. Are you happy about how I found Q1 by hand, right? Now, if you go over here, There's 9 numbers as well, not surprisingly. And the 5th one along is 1, 2, 3, 4, 5 is this number here. And that's Q3. So 3 and 14. Are we comfortable about the process of getting a 5-figure summary from a list of data, right? Now, this technique is only practical when the numbers are relatively short. You know, you're not going to do that if there was 200 numbers. Would you agree? Nobody in their right mind is going to write out 200 numbers on a big long piece of paper and trying to figure out where the heck Q1 and Q3 are, right? That just ain't going to happen. We use software, right, to do that. But it's helpful, I think, to see where these numbers are coming from, because if you just rely on software, oh, you plug some numbers in and some numbers come out. I don't know what they are. They tell me Q1 is 3. I don't know what that means. I don't know how they did it. I'm not even sure where it is. Do you at least get a visual idea when you do it by hand, what you're finding? So that's why we're doing this, not because I expect you in real life, if you ever needed to do this, that you would do it by hand, unless it was a very small list of numbers. Wouldn't you go and do it in computer software and just say, here's the data, tell me the 5-figure summary. Yeah, I'm good to go. Now, what's new or what's added is this thing here called outliers. I like the name outlier. An outlier is a number, right? It's part of the data, but it's a particular number that's extremely different from the others. So outliers they always live on the outside of the data. So it could be an exceptionally small number or an exceptionally large number. Now, as I look at this data, would you agree that 1, although it's small, it's quite similar to all the other numbers that come after it? On the other hand, would you agree 89 is a bit of an issue? 89 is a candidate for an outlier. All that I mean by that is that it's probably an outlier, but we still have to check, right? We don't like statistics where people just decide, yeah, 89 is an outlier because I think it's kind of weird and big and it's different from the other numbers, right? That's not a good way of deciding something. So there is a test for it, and this is the test down here. And the test uses the interquartile range. So let me get that. The interquartile range, IQR, is this fella, 14. Take away this fella, 3. And the answer I get is 11. So the interquartile range is 11. It kind of measures the range where the middle half of the data is, right? The middle 50% from smallest to biggest is about 11 numbers apart. And this is it kind of written down in English. There are 2 kinds of outliers. There's outliers that are really big, which would be 89. And then sometimes there's outliers over in the small side, right? They could be really small. And this is the test. If your number is bigger than Q3 plus 1.5 interquartile ranges. So let me do a check on 89. Q3 plus 1.5 interquartile range. Q3 is 14 plus 1.5 times 11. If you go 14 add 1.5 times 11, you get about 30.5. So you will be an outlier. I should say you'll be a big outlier if you are more than 30.5. Okay. Would you agree that 89 qualifies as an outlier? Right. Now, do you see there's no more guessing because everybody in statistics uses that same test? So if you were in research and you were collecting data and you got one really weird number that popped out and you really didn't like it because it kind of screws up everything, right? You might think, well, what does one big number do? One big number can do all sorts of really dangerous things. Give you an example. Suppose I was interested in the average wealth of students. And the sample I collected was a statistics class that I had. And I found out how much money Cheyenne was worth and how much Ashton was worth. And by sheer bad luck, one of Bill Gates' children was in my class. Can you imagine that the answer might be, I'm worth $100, I'm worth $500. If I sell my car, I'm worth $20,000. And then Bill Gates' son, I don't even know if he has a son, says, I'm worth $400 million. Can you see that might screw up the average value for how much people are? Because if you stick 400 million with everybody else, aren't you going to get, well, the average people in my stats class is 2 million. Well, it's not really, isn't it? Everybody else is a few thousand, and 400 million screws up the whole data. So outliers are notoriously dangerous things, because if you use them in your calculations, can't you screw up your numbers so they're unrealistic for the other 99.9% of the people? And so we need a way of identifying them. Now, I think if Bill Gates' son was here, I probably wouldn't need the test, right? 400 million, boom, yeah. But can you imagine if I said to you 49? Suppose that 89 was 49. Would that be an outlier? Well, we know the test, and the answer is yes. But would 49, for some of you at least, would 49 look not that far away? So maybe it's just big, but not an outlier. How about 39? Does 39 seem a little bit okay? Just pretend we didn't know this test. Can you see that subjectively then it's very difficult for everyone to agree without a test, right? Without a way of saying, this is how you find who an outlier is. So we all agree on this, and it makes life easy. So there are no choices. You are not allowed to pick somebody and say you're an outlier. Secondly, just because I thought of it, isn't it possible to have two really big numbers? Can you have two outliers? And the rule is, if you are bigger than 30.5, you're an outlier. You could have 5 outliers. Can you imagine you have 6,000 data points? You could have 5 outliers, couldn't you? You could have 5 exceptionally large numbers. It's not that unlikely. So don't think of an outlier as a unique, there's only one. There could be 2 or 3. And don't think that the last guy has to be an outlier. See if that last guy there was 25, wouldn't that be a normal number and you'd be fine? There'd be nothing special about it. So you're not guaranteed outliers. There might be none. In fact, in a funny kind of way, you don't want outliers because they screw things up. But you could have 2 or 3. And here's our test. Now, what am I going to do? Well, I'm going to do a box plot of this data. But when there is an outlier, we change the box plot. Now, I'm going to show you what the box plot would look like if we just use the 5-figure summary, which is what we typically do. So I'm going to start at 0. I'm going to finish at 90. I'm going to go 10, 20, 30, 40, 50, 60, 70, 80, 90, right? I know that's probably not very symmetric, but it gets the gist of it. And the smallest number is 1, so it's about there. 3's about here. 9 is about here. And 14 is about here. And 89 is about here. Would you agree that visually that is not a very appealing diagram? You see that really is very, very distracting, and it's not really accurate. It's not really telling you what the data is like. So what do you do when you have identified an outlier, in this case 89? Well, your data changes. 23 becomes the most important number now. So I'm going to start at 0 and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20. And the minimum is going to be 1. Q1 is going to be 3. The median is going to be 9. Q3 is going to be 11. And the maximum isn't 89 anymore. The guy that we're going to use for the end, I'm not going to call him the maximum because it's still 89, but the second to the end, right? The next number up is this guy here. Can you see that my box plot is, I'm using more of the real estate. Can't you read off where Q1, Q2, and Q3 are? And probably the first and the last number. Would you agree you could read them off? If I gave you this, would you have a real hard time trying to find out who the median was? You'd have to guesstimate a lot, right? Now, what do you do about the outlier? Well, there are a couple of things you can do. One of the things is you put a little asterisk down here and you just say outlier at 89. The other way that you do it is that you draw this picture with a change. You finish on 23, which is here. That's missing, and you do a little dot here. So I'll try and imagine what it might look like. Box plot and a dot. Me personally, I think this version is just easier to use, and you can still see who the outlier is, right? Would you agree in this version here, the only benefit you get is you don't have this big ugly long line? Technically speaking, can you see that the data stops here and then there's one number at the end? And so I can look at this and I can say, oh yeah, I can see most of the answers, most of the numbers are in this range and then a funny guy up there. And here I can see most of the numbers are in this range and then there's a funny guy at the end. Are we cool with how to test for an outlier and how it affects what the box plot, how you adapt your box plot to cope with any outlier that you may have? Right, now if you don't have an outlier, the box plot's the same box plot that we did yesterday, right? Everything's the same, no real changes. Any questions, or are we good so far? Okay. We're going to use salt to get a 5-figure summary and draw a box plot. I think I actually did that yesterday, but that's not a bad thing, so I'm going to do it again. Just going to move some windows around. That can go there, that can go there. And I'll go into student view. I think I need to do that. Okay. Problem with moving windows around is that I move them on top of things that I want to see. All right, here we go. I think you're looking at WebAssign, at least I hope you are. If I see some nods, I'm moving on. Yeah, got a nod, good. All right, we're on numerical summaries still, so I'll click on that. Click, oh, I just recognize something that I want to do. Since it's here, I'll do it. Students in a statistics class wrote as many letters of the alphabet as they could in 15 seconds using their other hand, right? So in my case, it would be my non-dominant hand would be my left hand. The figure for this exercise is a box plot that compares the number of letters written. So you can see the spread of the self-identified males and then the self-identified females. Do you see that they've got a dot at about what, 20, good grief, what kind of scale is that? That's stupid. How can you have 5 little marks when it's whole numbers, right? 23 letters, 24. Anyway, can we pretend that's 24? That dot.
What do you mean?
Right. Well, if you look at 23, there's 1, 2, 3, 4 dots. So how can you do 23 and a half letters? I'm just annoyed about the little marks that they made between 23 and 25.
Maybe
it should
none
have
of
just
them
been
show
23,
up on the.
one little mark, 25. Yeah, maybe I'm just being pragmatic. Right, would you agree that the females, there was one female who was an outlier at 24? And do you see what it looks like? So if you're wondering why is that dot there, she, whoever she is, was an outlier. Seems unusual based on the rest of there, but I guess they did the test. And now you can, figure out the rest. Now, there's another outlier for you. So this is the question I was trying to get to, or at least one like this. Here is a whole load of data to do with people's cholesterol level, and it's for 20 individuals. And here is the 5-figure summary, and here are the box plots. And whenever you get a question with this big orange, use salt. If you click on it, we should be able to get this. Looks good. So far, so good. It's changed. Right. If I go to descriptive statistics, anything that's check marked will appear over here. Let's suppose I don't need those. Can you see my 5-figure summary? So 154, 174, 191, 199, 236. You see how easy it is to get 5-figure summaries? Hit the salt button, go to descriptive statistics, and basically read off whatever it is that you're interested in. Now, if I hit charts and I go box plot, I'm going to have to shrink the size because the window size is confusing it. Select a variable, cholesterol, and there's your box plot. It does it vertically, but if you turn, yeah, exactly. If you turn your head on the side, can you see what the box plot would look like? Can you see the guy? And they've got numbers on the side. So actually, you could probably get your 5-figure summary and your box plot all at the same time.
Professor?
Yes.
Mason's in the waiting room.
Mason?
Yeah, he lost connection and he's trying to get back in.
Thank you for telling me.
Yeah.
I've just let him back in. Thank you. Okay, are we comfortable now? I can't tell you. Well, I've put a dot on that, but that might have just been me in the passing by. One of those 4 pictures will actually be the correct box plot. Wouldn't you use things like where the median is, maybe to decide which one of the 4 fits? Right. There's another set of data. This one is asking us, do any of the data qualify as an outlier? Okay, now when I look at this data, it's all jumbled up. So I have to do a kind of quick scan in my brain. What is the smallest number that you can see in this list? I can see 110. Is there anybody lighter than 110? Have I found it? Do you agree 110 is as light as it's going to be? Okay, now if I go to the maximum, I think it's what, about 213? Is it something bigger than 213? Right. Right. It's a bit hard, but if I wrote those, can you pretend I wrote that data in order? The possible outliers are always at the end. I think 110 might be the outlier. So I'm just going to write that down, 110. And it says here, identify any outliers. Now, if it was an outlier, I would type 110 in here, right? But I'm not convinced yet that it is. So what I'm going to do is I'm going to get a 5-figure summary so that I can get the interquartile range so I can do my test. So here goes. Hit that. Oh, the data's been transferred. There we go. Descriptive statistics. I won't write down everything I need. I know that Q1 is 180, and I know that Q3 is 198.75. So I'm now going to skip to the white page, and I'm going to check, is that 110-pound person a very light outlier? Okay, so that's a guy I'm going to test. This is going to give me the interquartile range. So it's Q3 take away Q1. So I'll go to my calculator and I'll go 198.75 take away 180, and let me do that again. 198.75 take away 180. There we go. And I got 18.75. And the test for a low number is Q1 take away 1.5 interquartile ranges. So it has to be smaller than that guy. Okay, let's see who that is. That's 180 take away 1.5 interquartile ranges. That's going to be 100 and that, take away 1.5 times 18.75, and the answer I get is 28.125. So it's 151.875. So if you are going to be an outlier, you have to be smaller than that number. Would you agree that that is definitely an outlier then? So I do have an outlier. I think the way the question was phrased is, if there's more than one outlier, so you go in the box and you take it 110. If there's more than one outlier, you put a comma and write the next one down. Can you trust me that there aren't any more outliers? Because I know the answer, right? The next biggest person is okay. He's safe. He's not an outlier, right? So far, so good. Now, the rest of that question, when asked as something, oh, by the way, do you know these 9 people? These are 9 rowers on one of those, do you know those row you see in the Olympics where there's 9 guys on one big boat? And isn't there a little guy or girl with a big megaphone going, 1, 2, 1, 2? Do you know what that person is called? You got to hit a space bar. What's the person who does all that shouting on rowing?
Are they called an outlier?
They are in this case called an outlier, but their job is a coxswain. And the question you can't see is, who do you think it is? And I think it's this person, because in the rowing, isn't the guy with the big megaphone or whatever they use shouts? Don't you want them to be really, really light? Because having a big heavy version of that guy isn't going to help you win any races. So that was nothing to do with statistics. So when you come to that question and you say, what on earth is a coxswain? That's who he is, and that guy there. And it could be a girl, I call guys. Guys are girls and men. I just use the word guy for everybody. Are we good with that? Right. Now, before I move away from outliers, let's give you a usage of outliers. A medical example. Can you imagine that we've collected lots and lots of data about the human body? And in particular, can you imagine that we've collected thousands of people and we've collected their blood pressure? And there's going to be a magic number. I don't know blood pressure. Somebody tell me a number that's really big. If you had a bigger than this, you got problems health-wise. A blood pressure that's really big. Otherwise, I'm just going to pretend I know. Any in the nursing program, tell me what a very high blood pressure would be. Systolic one, if you like. Okay, you're getting my answer. It's 190. If you are bigger than 190, you've got a problem. Agreed? Too high. If you're bigger than 190, you are an outlier. Where does that 190 come from? It comes from Q3 plus 1.5 interquartile ranges. So do you see that number isn't arbitrary? Do you see that magic number? If you're bigger than this, your hypertension or whatever fancy words they give for having too high a blood pressure is, you get it by using the boundaries on your outliers. Won't there be another boundary to the other side that says, hey, your blood pressure is far too low? Well, the one over here would come from there. So the numbers that they associate with medical levels, right? What's okay, right? What's the okay range? What's the I'm a bit big range? And what is I'm really in trouble range? You could get that from a box plot. Now, imagine you've got your box plot, and at these points here, I shouldn't really put lines. These are the boundaries for outliers. Then you would do something like this. If you're between here and here, that's the normal range for potassium, for blood pressure, for whatever it is. If you're up here, you might not be ill, but it's a bit high. If you're between these numbers, you're a bit low. If you're out here, it's dangerous, right? You have a dangerously high blood pressure. And if you're over here, you've got a dangerously low potassium level, blood pressure, whatever it is. And don't you typically start getting medication or very quick close examination? Because I think if your blood pressure goes far too high, couldn't you be in danger of taking a heart attack? And if it's really low, couldn't you be in danger of fainting any minute, right? So if you went to the doctors, you'd probably be getting treated right away. You'd probably be getting medicine in this range, and nothing would happen to you if you're in that range, right? Whatever you're doing it right. Are we good? Are we happy with outliers and how they can be used in other ways? So the last guy on my list is how to create a dot plot. And oops. I'm going to use you lot again to get some data. And then I'm going to create a dot plot by hand, and then I'll show you how you can use salt to do a dot plot. What shall we ask this time? Okay, looking for volunteers here. Tell me how many different countries in the world you've been to, and America counts as one. And if you don't know, do a guesstimate. Right, I go for it. Shout
One.
out a number. How many countries have you been to?
4.
4. I'm going to put 1 in because I know one of you haven't left America, right? So I'm doing it for you, right? You're covered. Right, give me another number.
3.
Just keep shouting until I've got a reasonable.
3.
2. 7.
15.
9.
Oh, I like 15. 9. Couple more.
4.
4. One more.
3.
Right, okay. Now, you start like you would with a box plot. You start with a ruler line. I know the smallest number is 0, but I think it's worthwhile putting nothing in. And then you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And if you have time and patience. It's a very primitive, but it's kind of useful. And you don't even need to put the data in order, which is kind of nice. So you've got a 1, then you've got a 4, then you've got a 3, and then you got another 3, then you got a 2, then you got a 7, then you got a 15, then you got a 9, then you got a 4, and then you got a 3. Would you agree that that is dead easy to do? And that is number of countries visited. 15 countries. Okay, whoever said 15, this is not to do with stats, I'm just nosy. Who was it and how come you've been to so many countries?
It was me. I like to travel.
Good reason, nothing wrong with that. I'm a little bit luckier than you because of where I've came from. There's a lot more countries to visit. So I've probably seen, yeah, probably 15 countries. I wouldn't, maybe not 15, maybe 12 to 15. But it's easy. I mean, when I was in Scotland, you know, you could fly to Paris in about 2 hours. I've been to Italy quite a few times. It takes about, I think, 3.5, 4 hours to get to Italy.
Yeah, my parents lived in Italy for a while, so they went all around Europe, and then my dad got stationed in Guam, so we've been all around like Asia and stuff over there. So my parents have been to quite a few countries.
And they didn't take you?
I wasn't born yet when they were in Italy, so my sister got the chance to go around Europe, and then when we were in Guam, I traveled around Asia and stuff. So that's why I was 9.
Ah, okay.
Yeah. So my
It's
sister got Europe, and me and my brother got Asian countries. So we kind of
okay. That's kind of cool.
yeah.
I know America's huge, so I mean, almost every state is like a country. You know, it's that big. Right? Are we happy with dot plots? Because we're almost finished. I mean, if I give you any set of data, would you just basically draw a ruler from smallest to big and do it? In dot plots, they're not interested in outliers, but couldn't you figure out the 5-figure summary and see whether 15 is an outlier or not? My gut feeling is that it probably is, but there's no guarantees. Just because I think it is doesn't mean it. So if I wanted to check is 15 an outlier, I would have to do the 5-figure summary, get the IQR, and then do the Q3 plus 1.5 IQR tests, right? So I'm not going to do that. For the last thing then, I want to show you that WebAssign using SALT will give you a dot plot. So I think I've got it set up here. I mean, it's very user-friendly SALT, I think, anyway, for the most part. So let's show you what you've got. Here you have a set of data. Students in the statistics will cost about how many minutes do they typically exercise in a week? And these were self-identified women, and these are self-identified men. Okay, so hit the salt button. Go in, oops, wait till it finishes doing its thing. Go into charts and graphs. Let's do self-identified women. Let's go dot plot. Yeah. You see how easy it was to do? If you wanted to do the males, I mean, it might look the same, but that is the male data, and you're done. Now you can use dot plots as a very simple way of just trying to visualize numbers. Same reasoning as before. Would you agree a dot plot's okay with 15, 20 numbers?